So this is our setup. This is the equation for the equilibrium constant. So when we're looking at this reaction, NH4 goes to NH3 plus H plus. This is balanced. It will be balanced for you. All of these coefficients are 1. So when we write the equilibrium constant for this, we will write the concentration of this product raised to the 1, but we don't need to put the 1, times the concentration of this product all over the concentration of our reactant. So this would be our equilibrium expression for, or equilibrium constant. So we would write something like this, where we have our bracket, and then we have NH3 bracket, and then times by another bracket, we have another product, we have H plus bracket, divide by NH4, 4 plus, and then I forgot to put a bracket around this. So this is what we would type in for the equilibrium expression for this equation. Okay, let's look at another question. So let's go to this review one that I have done already. So I'm going to, still in chapter 6. Oh, good, that wasn't review. All right, so we are going to look at this one, recognizing equilibrium from a sketch. So this one, we are still going to use this products over reactants. So if something is at equilibrium, the concentrations or the amounts of the products and the reactants don't change. So this is something that you have to do an experiment and see where the equilibrium sits. You have to measure the concentrations of the products and reactants. So if I'm looking at my equation, I have the equilibrium constant is equal to the products over the reactants. This is telling me at equilibrium, I will have this much products and this many reactants, and it's a constant amount. So if I look at the first picture, I have the reactants and they change into this other flower shape as a product. And I have the equilibrium constant here. So this is telling me that I have 5 products for 7 reactants. So I need, if I have 5 products for 7 reactants, then it will be at equilibrium. So I just have to count them up. So I'm going to look at the blue things and see how many I have. I have 1, 2, 3, 4, 5. Okay, I have 5 of those. And I have 1, 2, 3, 4, 5, 6, 7 of the reactants. So this one will be at equilibrium because I have 5 products for 7 reactants. All right, moving along. The next one tells me I need 1 product for, so I have my equilibrium constant that says 1 over 3. 1 product for 3 reactants. So The product is a purple one. So I'm going to look at all of these, and I have 1, 2, 3, 4. I'm going to write that down to help me remember. I have 4 products for how many reactants? 1, 2, 3, 4, 5, 6. For 6 reactants. So this doesn't simplify to 1/3. You want to make sure that it doesn't simplify. But if it was something like 2/6, then that would simplify to 1/3, and that would work. Okay, so if it simplifies, but this one didn't simplify. Okay, we have 4/6, which simplifies to 2/3. So that is not at equilibrium. So we just put no, it's not at equilibrium. Doesn't match its equilibrium constant. All right, next one. This one says we have 3 products for 2 reactants. So remember, the important thing here is products go on top, reactants go on the bottom. So here we are counting, we need 3 of these for 2 of these. 1, 2, 2, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That definitely doesn't simplify to this, so this would be no. And let's look at the last one. We have, it says 4. So remember, if we just have a number, there's always a 1 on the bottom. So we need 4 products for 1 reactant. So remember, products over reactants. So 4 products for 1 reactant. So these ones are our products. We've got 1, 2, 3, 4, 5 products for, let's count them. 1, 2, 3, 4, 5, 6, 7. So this would not be at equilibrium. Great. Okay, let's go back to some other topics. Great, we're in chapter 6. Okay, this one, let's see, which one should we do? Let's do this one. So this one says hydrogen bromide and oxygen react to form bromine and water like this. So we have our chemical equation. Also, a chemist finds at a certain temperature the equilibrium mixture of hydrogen bromide, oxygen, bromine, and water has the following composition. Calculate the value of the equilibrium constant for this reaction. Round your answer to 2 significant digits. Okay, so, this one we're going to start. Let's do one. So the first thing that we need to do is write our equilibrium constant. So our equilibrium constant, remember, is always going to be the concentration of our products raised to their coefficient over the reactants. So here we have SO3 is a product raised to the second, because there's a 2 in front of there. So products over the reactants. So I have SO2 as a reactant to the 2 times by O2 to the 1. So then all I have to do is, instead of writing this number, I have to put in the, instead of concentration, this is pressure. So I have, at some point, at the equilibrium, I have SO3, which is 51.4, and then I square that, over SO2 is 51.4 squared times 38.9 to the 1. Okay, I don't need to put the 1. All right, so then if I look at this, I can just simplify this. You can type this all in your calculator, or you can simplify. So this is just basically 1 over 38.9. Calculate. So I'm calculating. Okay, great. So I'm going to pull out my calculator. I'm going to type in 1 divided by 38.9. And then I need to round this to 2 significant digits, so it's going to be 0.026. Okay. And then I don't know if it's going to make me put the atmosphere or not. All right, let's do one more of those just to see the process again. So this one, I need the equilibrium constant, which is products to the exponent over reactants to the exponent. So my products here, I have NH3 to the 4th times O2 to the 5th over my reactants. I have NO to the 4th times water to the 6th. Okay, so then instead of writing my compound, I'm going to write the concentration here. So NH3 is 0.94 molar. We don't need to put the units. Times O2, 0.32 to the 5th. All over NO, which is 1.4 to the 4. Times water, which is 1.1 to the 6th. And then this mess I will put in my calculator. So 0.94 to the 4 times 0.32 to the 5, and then all of this needs to be divided by 1.4 to the 4, and then times by 1.1 to the 6. So let me just make sure it looks right before I type it in. Okay, and then I push enter. And I got this really small number. So I'm going to, the ALEKS calculator does this for me. I can just put it in scientific notation. So I'm going to do that. 3 point, I need 2 significant digits, 3 point. The other thing I can look here, these are all in 2 digits. So probably need 2 digits. 3.8 times 10 to the minus 4. And let's check that. Great. Okay, so that's how you do calculating an equilibrium constant at